Good evening, everyone.
Good, how are you?
Yeah, I'm doing well. Yeah. So, since two of our friends are new, let's have a quick glance about FE exam. Mm. So, tell me, guys, FE exam is for how many marks? Is it 100 or 120 or something else?
110.
Yeah, the FE exam is for 110 marks. And it means we have 110 questions. And how many subjects are there for civil engineers? You can see here we have around 14 subjects as per the FE syllabus. And where can we get this syllabus? We can directly get from the website, or we can see this syllabus from FE handbook. Then, so coming to the handbook, let's see how the handbook looks. So you guys might have already seen it. So the handbook has, it's like the partially open book test. We can't say that everything, whatever question we get in exam, might be having answer from handbook, but most of the questions like 70%, 60%, 80%, actually the percentage varies from exam to exam. So we can expect at least 70% of the questions from the handbooks. The handbook looks like this. And obviously we have the content here, different subjects. You can notice this. There are many subjects like thermodynamics, mechanics of materials, as well as chemical engineering. So the handbook is open for all the engineering fields. It's not exclusively for civil engineers. When you go to the exam field, exam center, and open this handbook, you will be able to see all the subjects, all the branches also. And then coming to civil engineers, so this is the common topic, that is units and conversions. You guys might have known by now. So tell me, what are the different types of units that we may get in the exam? Any idea? Any name?
Per meter square,
Yeah,
Newton
what?
per mm square.
Yes, you're right. Actually, what we name that system? Newton per meter, etc. Newton
SI
per mm.
units. SI
Yes,
units.
we call it as SI units. What is SI units? Its full form?
Standard
It's actually,
international units.
yes, it's international standard or standard international. And apart from that, even in the handbook, it is mentioned the questions can be from the other units. What is those units?
Pounds per feet.
Yes, your examples are right. Your examples are right. Pounds per feet, so and so. We call this as United States complementary. I don't. This system, United States, what we call the C as complementary system. Something you can see somewhere here. So basically, it is a US system. So these two are the systems and the units you can get in the exam, and you must be thorough enough to convert the answer as per the question. If they say in the options A, B, C, D, suppose they say that a person has traveled from A to B, the distance was 10 miles, and he took some around 2 hours, then what was his speed? They may say. And in the answers, the options might be in meter per second, kilometer per hour, and meter per second, so on so. So you must be free enough, well practiced enough, so that you can get answer in any form they want. No issues with the practice with the subject. Each and every subject obviously will get plenty of practice in doing the units. And in the units of conversions, you can see there is a conversion factor table here. So if you want to convert something into some other thing, we can just multiply this something. If you want to convert some centimeter into inches, you can directly see here. If you want to convert 2 centimeter to something dash inches, you can simply multiply 2 centimeter by 0.394. So 2 into 0.394 will give you the corresponding inch. So this is a first class. I'm not jumping into the subject. So it's my general approach. So I will do whole to part analysis. In surveying, in the last class, you might have seen this approach. Whole to part approach. We'll learn entire subject at once, basically what are there in these subjects, and then we go deeper into deeper. Okay. And yes. So you guys know I do This is my notes, mechanics of materials. The notes is well framed with plenty of examples, and this notes will be shared by today, and the entire PDF will be visible throughout the session. Yes, so everything is here. No need to worry. Every day you can go ahead and check the notes. Coming to the syllabus, let me open this handbook. This is my handbook which you get in the exam. Let me go to the last few pages where we can see the syllabus. So yes. So this is the syllabus for civil engineering for FA exam, which is CBT. What is CBT?
Computer-based test.
Yeah, it is computer-based test. It is not a handwritten test. You have to pick up the answer in the system, in the desktop. How many hours we have for this exam?
6 hours.
Yeah, it's 6 hours. It will be in two stretches, morning half and second half. And you can see here the exam uses both the international system of SI and US customary system, that is USCS. And coming to the syllabus, you guys have, most of us have studied statics in the structural subjects, and you guys have studied surveying. And what are the other subjects you are taught?
Highway engineering.
Which one?
Highway. Transport highway.
Acha, highway. Okay, transportation highway. So that's good. Okay. So coming to our subject, mechanics of materials, you can see how many marks it has. It has around 7 to 11 marks out of 110. Suppose if our luck is good, we may get around, let us say the average, that is 9 marks. So how many percentage of marks we can score by this 9 marks? Approximately?
8%.
Yeah, it's nearly 8%. So if you practice this thoroughly, it's a very simple subject and we can get 8% of the marks. Okay. Coming to the content in the mechanics of materials, we have the shear and moment diagrams. We'll see it. Obviously, some of you have remembered this is nothing but bending moment diagram and shear force diagram, which we have discussed some tips in statics. New guys, no need to worry. Everything will be revised from the 0 level. And the next thing is stresses and strains. You will see what are the stresses, what are the strains, and then we can see the deformations. We also see what are the deformations means, and then there is a combination of these stresses. There are like axial stresses, torsional stresses, bending stresses, and there can be combination of them. You can see what will be the combined effect of different stresses, and there are some phenomena called principal stresses, Mohr circle, so and so, and then elastic and plastic deformations. Actually, this elastic and plastic deformations, it's like if a material, like if you take a spring and if you stretch it and if you remove it to your hands, if you come back to its original position, we can say that behavior as elastic behavior. If you take the same spring and stretch it very hard that the string starts stretching and with it starts not regaining its original position. So such deformation are known as plastic deformations. It's very simple. We will see them. And this is what the mechanics of materials looks like, and it has 8% weightage. So yeah, let me open the RAF. So today is the first day. So day 1, fine. Likewise, every day, like statics, what I was doing, I was writing on this rough and I was sharing this rough page. So mechanics of materials, which is having around 8% of weightage. Well and good. Now, you guys tell me, what is the meaning of this subject? Just give your random expected answers. What do you think it could be?
I think it has something to do with the behavior of material under forces, stresses, strains.
Perfect. You're very precise. Your good name, please?
Shamroz Khan.
Shamroz. Okay. So our friend Shamroz Khan has said that mechanics of materials is like studying the behavior. That's very good. Of materials, you're right. Due to forces. Well and good. Any other answers? Someone want to modify it or enhance it? Any new answers? You can proceed. This is the right answer. I agree with this. It has many other definitions. Try it.
What about the
It's the
physical
study of-
attributes?
Yes, please.
Physical attributes of materials under external forces or pressure.
Yes. So your name, please.
Samir.
So Samir has given one new improvement in this definition. Actually, it's a studying the behavior of materials due to external forces, to be very precise. So the definition has improved. Any other further improvement? I will say the behavior is of many types. It can be external behavior, internal behavior. Which could be this behavior? Is it internal or external?
I think it covers both.
No. In mechanics of materials, we'll study only, basically, mostly 90% we'll study internal behavior. Okay. So the definition finally sums up like this: the studying the internal behavior of materials. I'm not worrying here in this subject whether this material is part of a beam. I'm not worrying whether it is part of a column. I'm not basically worrying. Studying the internal behavior of the material, which is a part of beam or column, whatever it might be, due to external forces acting on this material, is known as mechanics of materials. So, yes, sir, a quick question for you. What happens if I study the behavior, either internal or external, instead of material, if I study a beam, or if I study a column, or if I study a truss? So what subject it gonna become?
Statics,
No. Any other answer?
mechanics.
No.
Structural.
Yes. It's not even dynamics, it's structural analysis and design. If you slightly improve your subject, like if you start studying about the major structures like beam, column, slab, etc., then it's gonna become structural analysis. You guys are right. Now, I'll go a bit deeper, not deeper, backwards. What was the previous subject come for this mechanics of materials? Where we study, rather than stress, we study only force. We study, yes, you are right. The prerequisite subject for this mechanics of materials is statics, which all of us have studied except two of our friends. But anyway, this whatever subject I teach including all the basic topics from here, so no need to worry. So in statics, tell me guys, there are previous participants, what are the things we studied in that statics?
Tension, compression,
Or what is the tension, what is compression, what are they?
moment.
Forces.
Yes, they are forces. Actually they are forces, right?
Forces, component of force.
Perfect. Your brains are now opening. Like, that's good.
And
Components
there
of
was
forces.
moment of
Resultant.
beams and trusses.
Okay. See, that's good. The flowers are opening, resultant of forces, and then
Moment.
Equilibrium of rigid bodies and equilibrium force
yes,
moments.
before equilibrium, we learned something called moment. And I still remember some of you has given example of door, which I really liked it.
Couple.
And then
Yes.
couple, perfect. So example of couple in practical cases.
Water bottle.
Yes, water bottle. That's perfect. Where there are two forces involved in opposite direction. You can notice when you try to open a water bottle, one finger will be pushing it and one finger will be pulling it. So that's good. After the couple, then we jump into equilibrium for a body at rest. And then we studied equilibrium equations. And then we studied the beams, how to find their reactions. And then their corresponding shear force diagram and bending moment diagram. It's some tips, not basically, we did not jump into what is shear force. We did not jump into what is bending moment. And then after beams, I forgot what we
Trusses.
were.
Trusses.
Yes, perfect. In the beam, in after beam, we studied trusses. In the trusses, what we basically studied? Yeah, in the
Which
trusses.
resultant forces or acting on nodes.
Area, shape, moment of impression.
Yeah, in trusses, we basically studied the guys who are not working in the job, right? We try
Determinate
to.
and indeterminate.
Yes, you are right. That is
Zero
also one of the.
forces.
Yeah, we try to recognize zero force members which are not taking any load, and we also studied determinate and indeterminate structures. Also, we studied after the stresses, we have studied friction. Sorry, before that we have studied area and their corresponding centroid moment of inertia, and then we went for friction. That's good. You guys have recalled it. If you notice one thing, can you guess the formula for stress? Even though I did not tell you what is stress, you might have heard somewhere else. What is stress?
Workload.
Okay, it's a workload. Okay, in workload is in practical case. Technically, any formula for stress, if you remember.
Is
King.
the stress basically like pressure, force per unit area?
Okay, pressure. There is one word called pressure. That's again different topic. Actually, you are almost right. That is force per unit area. So you can notice this. We have taken force from here, which we learned the definition, and we have learned that area, different shapes have different areas, and the combination of these two, that is force by area, is nothing but stress. And basically, if I tell you, since we are studying, okay, since I am saying the internal behavior of a material, stress is basically it's an internal resistance force by per unit area of the body. I will tell you exactly what stress. We have plenty of time. So that's good. The definition of the mechanism of materials is studying the internal behavior of the materials due to external load. Now, the internal behavior of this material is nothing but we call it as stress. Stress is nothing but the internal behavior. So in this subject, we're gonna study the stress due to different external forces. And after this stress, we'll study strain. Any guess what could be the strain?
Strain is the definition of deformation. It is essentially change in length
Hmm.
by original length.
Perfect. The strain is
PL by
something related. Yes. Okay, you are very well ahead. That's good. The strain is basically the thing that is related to stress. So it is nothing but change in length by original length. And yes, I will not tell the definitions deeper. After the stress and strain, we'll study stress-strain relationship. There is some constant relationship between these stresses and strains. So if you take a rod and if you fix it here, and if you try to pull it with some load, so when you pull it, this material is made of small particles, which basically we call them as atoms, isn't it? A material is made of atoms, and each atom is connected to each other by interatomic forces, interatomic attraction forces. If you zoom it down, you can see it's like a family, mother, father, son, daughter, friends, etc., etc. Is no Fast and Furious family. There is a meme. What we say, family is everything. There is like interatomic forces like this. Each atom will be attached to neighboring atom tightly through some forces. When you try to pull this member, what happens? It tries to elongate, which we call it as basically deformation. When you try to elongate, it means that you are basically trying to bring a gap between these two guys. You are trying to bring a gap between friend one and friend two. When you try to bring a gap, but since there is already some attachment between them, there is friendship between them, they will try to oppose. No, we are friends. We're not gonna move apart from each other. So such resistance force happens at each atomic level. This is a resistance force which has developed due to their friendship, which is nothing but atomic forces. So when you cut a section, there will be infinite number of resisting forces that which are internal, So the stress is defined as the stress is equals to the internal resisting forces per unit area is nothing but stress. This is a basic summary. And again, the strain is nothing but, suppose it has defined by distance delta L and delta L by L. L is the original length that we call it as a strain, but itself is not the strain. There are different types of strain we can see. So we're gonna study stresses, strains, and there is some correlation between stress and strain, which is nothing but modulus of elasticity. You might have heard somewhere. After that, stresses and strains, we'll study the deformations. After studying the deformations, what shall we study? Let us see. Let us then study bending moment diagram and shear force diagram. And in the deformation itself, we can learn what are elastic and plastic deformations. Yeah. So basically, the subject is of only 5 topics. Just remember them: stress, strain, stress-strain relationship, which is nothing but there is Young's modulus, rigidity modulus, so and so, and deformations and bending moment and shear force. Now, okay, we will make it one more topic. The topic is combined stresses, which is the 4th one. When there are different types of stresses in combination, we'll study them. And then this is 5th, and then this is 6th. So let us study the 6 subjects in this 6 topics in the subject, and then we are done. Okay, let's see. So I told you that the mechanics of materials is just studying the internal behavior of the materials due to external forces. These external forces can be of many types. Now you guys tell me, what are the different types of external forces we can see in civil engineering or in any other cases? Tell me. Just random.
Wind, rain.
Yes, please. One by one.
Forces due to wind,
Okay, wind forces. That good?
Wind.
It is
rain.
okay.
No.
Snow.
Okay, snow load also will create some kind of force. Actually,
Seismic.
seismic, it is also a kind of force, seismic force.
Self-load.
Self-load, which is a dead weight load, that is also one kind of force. Anything else?
Live load.
Life load.
Perfect. Live loads, which will cause some forces. Good.
Live load is not external force.
No, live load is an external load. Suppose you are in an apartment, in your flat, you are standing on your floor, you are a live person, you are alive, and load coming from your weight is a live load on the slab.
Yeah,
So
but
isn't
like,
it
isn't that already calculated in factorial by 1.5?
we will
Essentially
calculate is
moving load.
yeah, we'll calculate with 1.5 as a factor of safety. We'll just overestimate the loads so that our design will be safer. That 1.5 is nothing to do with dead and live. It's like overestimating your external loads. Got it? So these are actually, my intention to ask the question is something else, but your answers are right. I cannot say they are wrong. They are right answers. So any other answers? What are the different types of external forces we get? These are the sources of forces. Like because of wind, the roof may get the pulling. That's why, during the cyclones, what do we call cyclones in US? You guys have different name. I forgot.
Hurricanes.
Yes, exactly.
Tornadoes.
Yes, hurricanes. So because of these wind loads, what happens if this is my building and if this is my roof? Because of the wind loads, what will happen? The wind will try to blow like this. Because of Bernoulli's principle, so and so high pressure to low pressure, the force will act like this. Because of this, the roof will depart and blow away in the wind. So you are right. The wind force is one of the different types of force coming to the snow load during the winter. There, the snow gets accumulated. Because of this accumulated snow, again, the slab gets some external load, which is a snow load. And coming to the seismic load, when this building is on the earth, when there is an epicenter within the surface due to plate tectonics, there is some relative motion. Because of that, there will be vibration, and this vibration travel like some waves. Because of the waves will touch the foundation. This basically, this earthquake force is transferred as a base shear, and this base shear gets transferred to the building, and which will be maximum at the top, and which we can reduce by base oscillators, or here we have some pendulum here in some structures. What do we call it? Does anyone know this? It's like dissipator, seismic dissipator. This is one kind of way to reduce earthquake loads. Anyway, and self loads, and live loads, these are different types of loads. These are the sources of the loads actually. My main intention was to ask the tensile force, compressive force, which are basically the axial forces. So you can see, you guys said live load. When you take a building which has a slab, and the slab rests on what? Beams or columns? The slab will rest on beams, isn't it? And then beams rest on what? Columns. And then columns rest on what?
Foundation.
Yes, foundations. That is footings. So when there is live load here, this live load is transferred taken by the slab, and the slab will take its load and give it to the beam. It do its duty. The slab will transfer the load to the beam. Now what will the beam do? The beam will resist some load and transfer this load at the ends, which are basically going to the columns. Now this column is taking this load ultimately. So tell me, this column is under compression or tension because of this load?
Compression.
Compression.
Yeah, it's a compression. So you can see the source of the load is live load. Obviously, when a man is standing here, its a source is live load, but the type of load, the nature of the load is compressive here. So which we call it as compressive force, which is one type of force. Because of this, there will be again stresses developed in this column. So the column will be having some length. It's like 10 meter, and there is some load acting. But because of this load, there will be compressive force. But naturally, we have created for 10 meter, but this external load is trying to compress it. So it is like giving the external load. So column will say, no, I am designed as a 10 meter and I have some concrete and steel in me. So I have some resistance power. I will not let you to compress. My 10 meter will be 10 meter itself. That's why it will oppose some resistance forces. This resistance force per unit area is nothing but again stress. And in this case, since it is compressive in nature, we call it as compressive stress. As simple as that. Tell me practically, I have shown you one example where the member is undergoing compressive force and ultimately the compressive stress. So give me one example for tensile force. Any example, not only civil field, any other field. Think of it.
Catapult.
Yes, please.
I mean, a rubber band when you.
Yes. So one of the example is rubber band. So you take
The
a rubber band
spring will also be in tension.
Yes, rubber band, when you pull it, it will be in tension. I agree. Spring,
Pulling a rope
pulling a rope,
during
perfect.
tug of war.
Tensioning
Tug of war.
the reinforcement bars.
Wow, that's a pretty good example. Nice. So reinforcement steel in a beam or even in a slab, which is under tension. Now, I'll just quick revise your basics. If this is a slab or a beam, and these are the end supports, and there is load acting like this, tell me, I have a steel rod. Where shall I keep it? Shall I keep it at the bottom or top? Shall I keep it
At
here
the
or here?
bottom.
Okay. Any other answers? We have three positions: top, bottom, and center. Where shall I
Bottom.
keep it? Yes, bottom,
Bottom.
bottom. You guys are right. So why we are keeping it bottom?
Because when we
Because steel is good in tension
tension
and
it
there
goes
will
up.
be tension at the bottom, compression at the
Yes,
top.
perfect. Because of this external load, the beam undergoes bending. When it undergoes bending, you know that the bottommost fibers will be under stretching. The stretching is nothing but pulling. Pulling is nothing but the tensile force. And since the concrete is weak in tension and steel is strong in tension, we'll take the help of the friend, that is steel, and give the strength to this beam. You guys are right. So this is where you can see the tension. And if you want to know further, this force is tensile force. And to be very precise, it is bending tensile force. Or bending, we can call it as flexural tension. So basically it is tensile force, but since it is happening in a beam which is under bending, and due to bending, we call it as bending tensile force, or bending is also known as flexure, then we can call it as flexural tensile force. That's good. You guys are very good example. Even you can notice you are staying in your room now listening to the class. Does your room has ceiling fan?
Yes.
So you guys have ceiling fan, and from the ceiling fan, you might have suspended some steel rod, and to this steel rod, you might have hang this, the ceiling fan like this. And because of this dead load of the fan, tell me, this rod undergoes tension or compression?
Tension.
Yes, this will be under tensile force. So basically, in mechanics of materials, what we'll study these 6 subjects, 6 topics: stresses, strains, stress-strain relationship, combined stresses, deformation, etc. Due to external forces. That external forces can be of many types. So the type 1 is tensile, tensile and compressive. Both are called. They're called with some name. Can anyone guess? The tensile force, that is external tensile force, and external compressive force is having some name because they have some common nature.
Axial force.
Yes, there we call it as axial forces. Why we call them as axial forces? Any guess? It's just English. Tell me.
Rotation.
Because the
They
force
rotate
moves
on
it away.
axis.
Yes, perfect. So even if I give this example where we have taken the column has some axis like this passing through its body, and the load is passing parallel to this or even through the axis or sometimes parallel to this axis. So that's why we call this compressive force as axial force. Even the ceiling fan example which I have given, the load that is acting on this is passing through the axis of this hollow section or solid section, whatever it might be. That's why even this tensile force is known as axial forces. If you see the
Can you give me
syllabus,
example of non-axial forces? Because everything is axial.
yes, please.
Would you mind giving me examples of non-axial forces?
Yeah. So, yeah, I have given an example here. Can you think of it in this rough page? There is one example hiding.
Unit load?
Anyone can? No. Yeah, unit load is also
That-
right answer, actually.
Okay.
Yeah,
The
live load, you are
fan
saying
will-
this?
In the beam, the load that the beam
Mhm.
has, that won't be
Mhm.
axial, right?
Yes, you're right. That's a very good answer. Actually, the answer lies in the definition of axis. The axis of a body is actually the line that is passing through the longitudinal length of a body. Suppose if I say I have a ring, I have a beam like this. For a beam, the axis is defined, the line that is passing through its centroidal along the length. Centroid along the length is known as axis of this material. Even if I take a column, the column is also defined like this. Generally, these are like prismatic members, and the axis is defined like this. So one of our friend has found that fact. So if this is the axis of the beam, you can notice this axis is in this direction, and the loads are acting in the perpendicular direction to the axis. So whatever forces here acting, that is, even though it is tensile force, I cannot say it is axial force. Actually, it is flexural. That's why I have saying it is a flexural tensile force. Got it? This is one of the example. We have different terminologies. There are different calculations of stresses. We'll see it. But this is an example where the loads can act not along the axis, but perpendicular to the axis. Even it can be inclined to the axis. The loads can be inclined also. There is no restriction on a beam. It can be acting in any inclination. Yep. So let's go to other type of forces. He has
I
said
have
many
one
times.
question
Yes,
in
yes.
this.
Yeah. Proceed.
Uh, what are lateral and longitudinal load? Like, is it the same thing that we are talking about?
Okay, the lateral and longitudinal loads will depend on type of element you are talking about. Let me say, I'll give, since it is a basics class, first class, we'll revise all the basic doubts, basic things. Suppose I will say what the example of lateral load or longitudinal load with a very pretty good example. Have you guys visited any workshop, any big factory workshop, or even in your BTech days or your graduation days? You guys, do you have visited a structural laboratories?
Yes.
Yes. Yes. So what are the things you guys noticed there? Something movable that is lifting the materials?
Please.
Yes. Pulleys. Yes, you are almost near. We have something called
Air.
girders.
Girders.
So this girders are generally, they can be of any shape, but predominantly they will be like ISMBs, that is I sections. And over these girders, there will be a crane or a car that is moving like this, which is having a pulley and which will be having a hook and which will be lifting the material from one place to other as per the need, Now, see, this is the beam that is from A to B. If you see from the side, if I cut this section, this beam might be looking like this. Something, it is like this. Okay. Now, one of our friend has asked me, what is longitudinal load and lateral load? Suppose if I apply some load on the top like this, in this direction, which means if I see from this view, that is section A, this will be like this. This looks like this. So tell me, what is this load? Is it lateral load or longitudinal load?
Both.
No, it cannot be both.
Lateral.
Any other answers? Tell me one more question, then I will make the things clear. So is this the axis of the beam? Can I say this as axis of the beam? This pink line which I drawn recently.
Yes.
So this line 1 is axis of the beam. So the lateral loads is defined as the loads that are acting on the sides. If they act from the side, we call them as lateral loads. Okay. And there
But
are
isn't
some
it
other.
transferred as a? I'm sorry, go ahead. I don't want to.
Yes, I'm going further. Suppose I am applying load from the top. Even suppose I'm lifting some material, some blocks here, some concrete blocks in the structural lab. Because of this block, the load is acting on the beam in this direction. So this is load P1, this is load P2. This P2 is actually the transverse load, which is acting perpendicular to the axis, but in the vertical direction. We call it as transverse load. And the load that is acting perpendicular to the axis itself, but acting in the horizontal plane rather than vertical plane. If it acts in the horizontal plane, we call it as lateral load. And coming to the longitudinal load, that is pretty simple. If someone is trying to pull this beam on either side along the axis, so which we call it as longitudinal load. So these are different types of longitudinal, transverse, and lateral loads. Basically, these types of loads has nothing to do with our syllabus, especially We don't deal with the lateral loads and even longitudinal loads. Generally, longitudinal loads are nothing but the axial loads, which are passing through the longitudinal axis. That can be tension or compression itself again. So coming to the notes here. Yep. There is something called different types of loads. I said you have studied tension, compression. There's something called shear. We have studied what is bending, and we are left with shear force and torsional forces. Yes. Let me open the rough. Can you guess what could be the shear force? Any practical example of shear forces?
Internal twisting force.
Internal resisting force. This
Twisting,
is
twisting.
this was also internal resisting force, which was a tensile load.
No, I said twisting.
Twisting.
Yeah, twisting.
So no. So you are saying what is twisting? What is the example for twisting?
Torsion. Twisting is torsion.
Yes, twisting is basically torsion. Okay. We'll talk of
Handshake
twist.
could be shear force.
Yes, perfect. Is it a hand shake or hand rubbing? So when you take your hand, take your both the palms, rub over each other. So rubbing your both the hands over each other, I can say that is shear force, because I will take the top hand like this. It is your top hand, and this is a bottom hand, bottom palm, sorry. And these are two surfaces. This is surface 1 and this is surface 2. When you try to rub your both the hands, you will try to give the opposite direction of motions. You will try to do like this. This will be front, this will be back. Again, this will be back, this will be front. When you try to do in such a way, there will be forces that have generated between these surfaces. So this kind of internal resisting forces that have generated parallel to the surface of the bodies, we call them as shear forces. So rubbing of the palms is a kind of shear force. This is a one kind of practical example. And any other example if you want, yes, please. Proceed.
What about pulling from two different sides? Could that also be
Okay.
shear
Pulling
force?
from two different sides. Let me mark this as some block. Okay. This is one block. And you are saying someone is pulling from here and someone is pulling from here, from both the sides. So
Yes.
if they are pulling on the same axis, then you say me, can it be shear or it should be tension or it should be compression?
With tension.
It should be tension basically. It cannot be shear. And if you want to know very precisely, suppose the block is like this and I pull it in such a way, I pull it from top here and the top here, then you guys are not yet deep into the subject, but I can say this distortion will happen like this. It's try to deform like this, and there will
A
be shear.
displacement.
Yeah, displacement. Actually, it's not displacement. We call it as deformation, because deformation is known as change in the shape of a material after applying some external load is known as deformation. And the
Okay.
deformation can be of many types. It can be distortion, that is completely changing the orientation, or it can be bulking, or it can be compression, it can be expansion, shortening. Basically, all these changes, we call it as deformation. Deformation is nothing but change in the shape. Got it?
Okay.
I may use different terminologies like deformation. It is a general term. It can be either stretching, it can be either, shrinking, or it can be either, expansion of a balloon, or it can be, a decrease in the size, or it can be change in the shape. Like if you take an eraser, if you twist it with both your hands, it is also a distortion, but we call it as twisting, the twisted shape, etc. It is
Okay.
we don't have any restrictions on these terminologies, especially for FA exam. Okay. Yeah, this is one kind of shear. And coming to the torsion, which is nothing but twisting, you take some material and you try to give some moment that is movement in the both the directions, in the opposite directions on either ends, then the member will deform like this. So such kind of force is known as torsional force. So basically in mechanics of materials, we study the 6 things, that is stresses, strains, and then deformations, and then combination of stresses, shear force bending moment diagram, and then the last
Breaking
thing,
point.
yeah, because of the external forces which can be of different types, that is tension, compression, shear, bending, torsion. This is the basic summary of the subject. And in tomorrow, we'll go deeper and deeper into the subject. So everything is crystal clear here, you need not to worry. So coming to the stress, there are very pictorial demonstration of what is stress. I have taken a rod here, applied some load, and because of the load, I cut this section because I have said the stress is nothing but internal thing. So I cut the section I have seen here. I can see the intermolecular forces that is resisting, and this internal forces will be equal to external forces due to equilibrium, and this internal forces by area we call this stress. And stress has some units in SI units and US units. We'll learn them and we'll do the example, and then we'll go into type of stresses, that is normal. In the normal stresses there are tensile and compressive, and there are bending stresses. They have plenty of examples. So it is just a summary, and we have examples. From tomorrow's session we'll start the subject clearly. So I'll request you to maintain a rough paper with you. We'll do the numericals hand to hand, and keep the calculators with you. And this notes will be uploaded today. You can even refer these notes prior. Tomorrow also, before the session, half an hour before, you can see the notes and you can start the session.
I
So
have
that's
a
it.
quick
Yeah.
question.
Yes, please.
Is it safe to say that there is a fixed point? Because all of these require a centroidal axis to be, there should be a 0 on a centroid.
Yeah.
Because the movement are only on the end points, as far as what I understand. There is no force particularly applied directly on the center.
Yeah. Actually, your concern is, I agree. Suppose this is my cross section of a rod. I take some, this is my rod. Your question is, suppose if this is my center of the rod, of the cross section, and this is my axis of this rod, and if the load is applied here, if I pull it here like this, suppose I fix it on a fixed plate, this end is fixed, and if I pull it somewhere here, that is with some eccentricity, it is a combination of tensile load as well as there will be some bending developed. So there will be tension. Because of this eccentricity, there will be some moment developed. Because of this moment, there will be some bending. That's why this member will bend along with some extension. It's a like combination. There we study the combination of stresses. I have said you right, combined stresses that comes into the action in this case. If at all I apply this load purely on the axis, concentrically, like over the axis, then there will be only pure axial force, which is pure tension. Got it?
Okay.
So you need not to worry. I will
Got it.
tell you in the topic, that is combined stresses, where the same material can be under tension as well as bending. The same material can be under tension as well as twisting, torsion.
You got it. Thank you.
Sir,
Yeah, yes,
sir,
please.
before you go, can we go over the shear example again?
Yeah, this is a shear example.
No, the other one.
Yes, shear.
Yeah. Yeah. So my question was, for it to be a shear force, both the forces doesn't necessarily have to act on the neutral axis, like on different axes. It should act on 2 different axes for it to be shear, or for it to cause certain deformation. Then we call it shear.
Yes. So it's a very good question. Actually, yeah, I will give you the clarity. Where is the notes? Let me say, yep. The shear force I can show you here somewhere. See, if I talk about the external force, let me open the rough page itself. let me say if this is my block, the 3D block, something like this, and it is like this and this. This is my 3D block. If I apply some load, something in this direction, it comes to the type of forces. This force, which I applied here, F1, we call it as normal force, which is acting perpendicular. We come to here again the new parameter, that is the phase on which the force is being applied. The definition of this force is now become the normal force. And then if I apply some load, something parallel to this, parallel to the plane of the, if I name this plane as A, B, C, D, E, F, and G. So if since this force F2 is acting parallel to the plane A, B, C, D, we call this force as, again, the shear force. It's not a normal force. So clear in this? This is the external force actually. But what I can say, there are some deep inner things. Since I am talking the word stress, if I say the word shear stress, suppose if this is my block itself from the side and applied some normal force only, that is like this, that is axial force, which is F, I cannot say there will not be shear in this body. There will be shear stress in this body. Why? Because the material is made of many small elements, and especially in mechanics of materials, we take every small element as some cube. So we call this as a stress element. On this stress element, even though the external force is only the axial force or just the normal force, I'll tell you the difference between axial and normal later. The internal element, there might be some element which might be undergoing shear stress also. Generally on the stress element, we represent the shear like this, parallel to the surfaces, and the normal stresses like this. So that is the case. We'll study in the upcoming subjects, especially in the principal stresses there. Coming to the more circle topic, you can guess it. The material is a very big body. To be in the microscopic level, material is made of different atoms, infinite number of atoms at different locations. So irrespective of the external load, there will be some elements where it might be undergoing only shear force. There might be elements where, shear stresses. There might be elements where it can be undergoing only tensile force. The best example, since you guys asked me, I will tell you, I will take an element, I will take the structural element, that is beam. Now what I do, I apply some uniformly distributed load or even a point load, whatever it might be. Because of this load, you guys know it pretty well. So this will undergo deformation, like sagging like this. Now, and its longitudinal axis like this. As I said, the material is made of infinite number of elements. This is known as finite elemental analysis, etc. If we go deeper, generally, you guys now tell me, if I take some element here, finite element here, and this is element 1, finite element 2, and this is finite element 3. So out of these 3 elements, which element could be predominantly in tension?
1.
See, it is in 1. Even though if we see as a whole, there is no direct tensile force, but element 1 is going that axial forces, that is tensile. And you can say predominantly the 3 will be undergoing compressive force, which is kind of axial force for this element. And tell me what could be the 2, which kind of force it might be undergoing?
Both.
So both, since it is it is affected by the both, like compression on the top and tension on the bottom, because of this bothness, it will face the shear forces only on this. And why I am drawing again the shear in this direction, also I have drawn here. There is some reason why there are shear forces acting in this direction, which we call it
Because
as
moment.
equilibrium. Yes, we
Yeah.
have to maintain the equilibrium. Since these two shears are causing the movement like this, but this element is part of this beam and this beam is at rest, it is not running away, which means that this element is also at rest, which means that equilibrium is satisfied. That means that some opposite direction moment also should be created. That's why some moment is developed like this. So yeah, you guys are curious enough. That's good. So from step to step, from zero to pro level, we'll learn the things from tomorrow's session.
How long
Any
is the
other
subject
doubts?
though?
I
1 week?
may take more than 1 week.
Oh, for sure.
Around 10 days, I may take it.
I kind of missed last week. So what exactly was in last week?
It's a different subject actually. It's a surveying.
So, okay, surveying. Yeah, cool.
So no need to worry. Survey has nothing to do with this. But I suggest the newcomers to revise our statics where there are basics like forces, components of forces, etc. etc. But those are not needed. Anyway, tomorrow's class, I will describe them again. Yep, that's it.